So this is the continuation of lesson 10. In lesson 10 we stopped at the state part, how the state part came on. So hope we know that it's not compulsory that the state part is going to come on. There's conditions for it. That is, if the frame didn't reach the allocated size in our register, that's when the state part comes on and starts padding the bit until it gets to that minimum allocated size. So after the state part, or we are going to get the state FCS, the frame check sum. This is the error checking state at this state. So this is the state I'm talking about, the state FC. This is it here, came all the way from here. So we're going to see how we turn on this state FC. So we turn it on using the start FCS, sorry, the start FCS. So this is the start FCS here. So let's see how this start FCS bit turns on. So this is it. So this is the OR gate. It's going to turn on two conditions, and that two conditions means is either when is coming is in the state data 1 or is in state pad. So these are the two conditions. Let's see the first one. So this first one says this condition must not be on, which is collision. There must be no collision. See it, I've highlighted it. There must be no collision. Then and that works, you see, it's the same for both states, for both conditions. There must be no collision at all for state FCS to come. So this collision, whenever there is a collision, the state is going, you cannot be in any state with collision. It's going to go to state differ. So we're going to see that later in this tutorial. Then the next condition, let's see the next condition. So this is it. Okay, this condition says is coming from the state part. You can see the state part is being highlighted. That is the first condition when it's coming from the state part. That means the second one will be when it's coming from state data 0. So let's see again. The enable min FM must be on. That is the state part scenario. That is when it comes on is in state part. And then the last, okay, let me shift it so you see. The CRC enabled must be on. So this CRC enabled comes from our register. Is a bit in our register. Whenever we set the CRC enable, it means that we want to add the CRC error checker to our transmission, and that is what determines if the state FCS is going to be on. If it's not on, we are going to skip this state FC, is going to be skipped. If CRC enabled is not turned on, that means you don't want any error check to follow the transmission. So let's see what happens in this second AND gate, this second one. So first condition says, let's highlight it. You can see the state data 1. It's coming from state data 1. Just as I'm telling you, you know this state data is 2, state data 0 and state data 1, but probably you won't be seeing it, but I'm seeing it very clearly here. Is in state data 1. I don't know, let me show you what I mean. See, this is a splitter where I split the two states. So you can see here that, see, watch here, what happens here. The bit 1 is position 0 top and bit 0 is none. That is, I removed bit 0. These are how the wire splitter, for people who don't use Logisim, I'm using a wire splitter here. So I split the two states and I'm taking only bit 1. I removed bit 0. You can see bit 0 is in no position, is none. Only bit 1 is in 0 top. So that is how. So whenever I say state data 1, it means state data 1. When I say state data 0, is state data 0. So the next condition that has to be TSN frame. At the end of the frame, that is when it can enter the state FCS. After sending our transmitted data, it has calculated the state part and then is now going to the state FCS. Then this condition says, if this condition is not on, let's see what condition is it. The padding, you didn't set pad, that is, it is not coming from the state pad, or this one says it's coming from the state pad and the enable min FL is on. So that's how we turn on the start FCS. So whenever we turn on the start FCS, we enter into this state FCS. Okay, so let's actually do an example and see and watch it come on. So I have the luxury to choose, because of this OR gate, I can decide to choose either of these conditions and make it to turn on. So let me see the one I'm most likely to use. So okay, oh, the whole states are in 0, so let me know. I won't be using this because I won't be using this one because the whole states are in 0. So let me use this AND gate and watch, and you'll watch it enter into the state part. So what's this condition? The enable min FM must be on, and we have to enable CLC for us to move into state FCS. It's very compulsory. This CLC enable comes from our register. When we're doing the register model, you see all these bits. So let me turn it on. I want to turn it on. Then as another condition, you see the state FCS is not yet on. Then the last condition, which is this enable min FL must be on. That is, it has passed the minimum. That means the sent data is okay. Once this enable min FL, enable minimum frame length, that's the meaning, enables the minimum frame length enables, it must be on. That means that the sent data has reached that minimum frame length. So let's turn it on and watch it go into state FCS. So as you can see, it has entered the state FCS. So the next one, let's watch this state jam. We already know that state jam is whenever there is a collision, but let's see how we can go into this state backoff. So this is the start backoff. Let's just watch how we can go into the state backoff. So this state backoff means that if within, there's this bit here, we call it, if a collision occurs within what we call a collision window. We describe it as a collision window. So this bit here, let me remove this. Hey, fuck. Sorry. This error case. This usually happens whenever I press Ctrl Z. Whenever I'm trying to remove this highlighter and the highlighter is not selected, it's always undo the last change I made to my logic. Sorry for that. Then we are here. Okay. So I was trying to explain how we enter this state backoff. This state backoff means temporary suspension during active data transmission. That is a collision that occurs within the collision window. If a collision occurs, the collision window is a timer. We're going to see how this collision window works. If a collision occurs within the collision window, it can be temporarily suspended for a while. See what you mean by collision. This collision window is going to set in one of the next subsequent tutorials we are going to be doing. We are going to see how this collision window actually, how the signal gets turned on. If a collision occurs within the collision window, it is treated as an active collision. At that point, we can suspend data transmission but not cancel it. So we are going to see what gives rise to this collision window. So assuming we are within this collision window 1 and there is a state jam, that is a active collision occurs within the collision window, we are going to enter into state backoff. But if it occurs if a collision occurs outside of the collision window, we are going to defer transmission. So let's see the conditions for state backoff. So as we are saying, if there is a state jam, that is an active collision occurs during data transmission. When there is a state jam, then this signal must be off, which is, let's see, random. We are going to treat this bit later within this tutorial. Random equal to 0. We are going to talk when we are going to deal with the random number generator. When an active collision occurs, the CSMA protocol says that if active collision occurs during transmission, that the transmitting host is going to wait for a random number of time before retransmitting again. So there is a sub-circuit called a random generator. We are going to treat it later, that generates this signal random equals 0. That is, when the random number counts down to 0, this signal comes on, and that is when we move into this state, the state backoff. So then again, the collision occurred within the collision window. You can see the collision has to occur within the collision window. Then this signal has to be low, which is retry max. So all these are collision detection signals. Collision window, retry max, random equals 0. Even this no backoff is also part of the collision detection signals. So in that model, when we are going to be talking about the random number, how to generate this random number that we use after data collision, we are going to see how to implement this state backoff properly. Then the state differ is a bit, this one is responsible for the state differ, this OR gate. So there are a lot of conditions for state differ. So okay, let's just treat them little piece by piece. One is for state differ. This condition is there must be carrier sense. That is, when there's active transmission and you are in state idle, that is when you go to, it's called the signal differ indication comes on, then you are going to enter into state differ. That is if you are idle, and that is when you are normally idle. That is not when you are trying to transmit. If you are in the idle state and the transmitting line is busy, you are going to stay in state differ until the end of the transmission. So whenever the whole transmission is done, you can continue again. So this one again, let's see this. This one say when there is a underrun. So a lot of conditions for moving into this state. So if you go through the code, the transmitter state machine, you see all these things. So there are so much. This video is already 40 something minutes already with the previous one. I think I'll end it here. The logic sim, you can send me an email if you need the logic sim circuit. I think the logic sim is very good for understanding the HDL code. Thank you. Subscribe to my channel, please. Thank you.